Okay, this is the video for how to calibrate the output voltage of the brick regulator and the input current limit. You will need a bench power supply capable of being adjusted continuously between 8 volts and 27 volts. And the reason for that will become apparent. And you will need a rare earth magnet, a large rare earth magnet, and you will need to place it over the magnet sensor, which is right in this location here, right near the M of streamer. Okay, the wording streamer goes across. Place the rare earth magnet there with the south pole facing down. Adjust the bench power supply for 8 volts. Right, when the bench power supply has been adjusted for 8 volts, you can then power up the device. The device will say, okay, I'm at 8 volts, so I want to enter programming mode. The magnet is present, that has to be the case, and then it will start flashing the red LED 10 times. Then it will start flashing the green LED 5 times. Before the green LED finishes, you must remove the magnet, and then the device will be in programming mode. It's intentionally a little awkward to do, so it never happens accidentally. Alright, I will power up the bench power supply. You will see the red LED flash 10 times, and I'll remove the magnet before we have 5 green flashes. There we go. Then the green LED will flash once more, and that says it's waiting for the first setting. Now, what you need to do then is to increase the bench power supply voltage to what you want the charging voltage to be. Now, for the batteries that we provide, the ideal voltage is 27 volts. That's nominally a 24 volt battery, but in the same way a 12 volt car battery needs a higher voltage to that. We use 27 volts. So we'll turn it up for 27. Just the fine adjustment to make it 27.0. We use the magnet again, and all we have to do, south pole down, is swipe it over the magnet sensor, and the green LED will flash to acknowledge, and then it will flash twice to say it wants the second input. So green flash to acknowledge the swipe, and then it will flash twice to say give me the next setting. The next setting is the current limit that is allowed on the input. The reason for that is that tapoos and hapoos are very sensitive to the amount of current they can provide. If the cable is very long, it doesn't really matter what the voltage is. It's not power, it's current that is important. And in this case, we have a formula where the current is the current that you want divided by 10 plus 10. So if we want half an amp, 0.5 of an amp limit, which is a nice safe limit, then you would have 5 amps, sorry, 0.5 multiplied by 10 is 5, and we add 10 to that number. So 0.5 of an amp is desired. You multiply what you desire by 10, so you get the number 5, and then you add 10 volts to that, so you get 15 volts. So we turn the voltage down to 15 volts. And again, do the fine adjustment to make sure we get 15 volts. We swipe the magnet again, and you'll see a green flash to acknowledge that input. And then the red LED will light up for a little while. That's indicating that those values are being written to the EEPROM of the device. Green flash to acknowledge. Red LED lights up to say I'm writing it to my memory, non-volatile memory. The device then enters startup mode. That is this device now programmed with the new settings. I will proceed to show you how we test that they're actually working. Okay, we turn off the output of the bench power supply. We adjust this current limit up. We adjust the voltage to a typical tapu output voltage, which might be about 38, 39 volts, something like that. It's a good example. We can open up the 2 outputs here. Oops, we lose that. Can take a multimeter, voltage output, select the range to be something appropriate, a nice fixed display. We can look at this output here, leave those probes inside. That's the type of guy I am. There's another multimeter. You can measure the other output. And choose an appropriate range on the other multimeter. And plug that into there. And then we'll see what happens when we turn on the voltage on the bench power supply. You'll see the device do the red and green startup, and then after a few moments we will have the battery output turned on, which should be this device here, 27 volts. We should get the flashing LEDs, and 30 seconds later we should receive the this device here, which is the GPS output, will turn on 30 seconds later. The reason for that is to stagger the, if we have two active devices here, stagger the turn on so the startup current is not excessive. So within 30 seconds this device is turned on and it provides the correct voltage. In this case 27 volts, which is what we'd already set the device up, if you remember. Okay, now we have to just double check whether the voltages are okay. What we want to do is to actually plug in a battery and check that the charging current is correct for a battery. I happen to have one here. I'll lift up the battery cable. Now remember, you can hot plug these. That's one part of the design, is it will change configuration when you plug in a battery. And what we want to do is to monitor the current flowing in from the bench power supply to charge this battery. So as I plug this device in, oh, see, I put the wrong one there. Move that over there. That goes into there. We'll have a look at that later. Okay, we plug in the battery into this one, and we can monitor. 1, 2, 3. Now you see that the current flowing into the battery initially starts off at half the maximum, and then the current will increase and it will go a little bit above what we set it up for. Actually it goes to about 0.6 of an amp. So but that it should actually stop around about 0.6 of an amp, and it shouldn't provide any more current flowing into the device. So even though the battery is quite depleted, and we should be able to see the battery voltage here, if I plug into this port, because they're both the same voltage, we will see that the battery voltage is in fact quite low at 21.7 volts. So the maximum current will be flowing into the battery from this device, and as you see here it's 0.6, around about 0.6 of an amp. Okay, and the voltage to the battery will slowly rise as it charges. Okay, so that is a device calibrated, and that is the new maximum current that is allowed to flow from the input, not on the output. The output will be higher than that because the power going in is converted to the power coming out. So as this is 38 volts going in, 0.6 of an amp, you'll probably find you've got around about 0.9 of an amp coming out into the battery because it's a lower voltage. And the power is the same. Power in is power out minus a small loss. Okay, that's it. Thank you very much.